slides from the book, but we're mostly going to use the worksheet. There's three types of measures most commonly associated with central tendency. Now, central tendency, you can think of the central tendency as the center of our distribution. In other words, where's kind of the center of this thing, that central tendency. There's three ways for us to look at it. We'll talk about them all, mean, median, and mode. But where the center of this is, you know, it's kind of like, well, the center of it's not over there. It's somewhere in here, like what Sarah was talking about, right? Somewhere about where I've got the marker. That's kind of the center. That's kind of the balance point of this distribution. So let's talk about them in sequence. The first one I talk about is the mean. The mean is what we know as the average. Okay? And the average is just adding them all up and dividing by 30. You've seen that before. Now, the way to add them all up and divide by 30, if you haven't done this already, I'll give you a minute or two to put it in your calculator. So what I've done, and I cheated because I taught this class before you came in here, but you should go to the calculator, go to Stat, or go to list 1. Edit, that's list 1. And I've actually put them all in list 1, and then I've actually sorted them. But you want to put all of your data in list 1. Put all 30 days worth of data in list 1. So take a minute, everybody put all of the data, all of the observations in list 1. If you got it in already, great. If not, everybody know how to put it in list 1? Everybody? Okay, if you do and your neighbor doesn't, help them. Okay, you have it in list 1? You got it in list 1? Okay, good. Andre, still calculator?
I forgot it.
Okay, why don't you move over, maybe Jalen will
Actually,
give
I
you.
know how to put it in there.
Well, yeah, I mean, just sit over by Jalen, because we're gonna be working with the calculator all night, okay? I mean, he's not a bad guy, I met him.
It's fine, I know how to put it in there. Get all of it.
And then when you get them all in list 1, I know you're working badly to do that. I want you to add them all up. And we can add them all up pretty simply on the calculator. By going to second list, which is post stat. Go over to math. Number 5 says sum them all up. If you go down to number 5, hit number 5 and say I want to sum up list 1. And this is actually called the sum check, which is actually done a lot in data input. All mine are in list 1, so I want to sum up list 1. It'd be really great, really terrific if most of you got 2458. How do I do it, Tyler? How do
Oh,
you
well,
get
the way he did it, you can go to second
list?
list, and then click on list 1. This is where the stat is.
The second list is second stat button, second stat. And I mean, there's a couple ways to get there, but I just went over to the math operation. Because I want to add up one of the lists. How many people got 2458? Very good, very good. Either we're all wrong or we're okay. You got a worksheet, Chase?
Yes.
That's good. Okay, excellent. All right, so if I want to take the mean then, if I get the the sum, the 2458, which is what we all should have. What do I gotta do to take the mean? I gotta add up all the data, which is what we did. This is a little notation, the summation notation. I add up every piece of data and I divide by n, which is in our case, what's n in our case? It's 30, right? So this is literally 2458 divided by 30, which hopefully will somebody tell me.
82 around the bottom. 81.93.
Okay, 81.933333 forever. How many decimal places should we use in statistics? 3? Nick says 3? Okay, we gotta vote for 3. Anybody wanna say higher or lower?
Depends on what we're calculating, think what our data was.
Depends on what our data was. So Matthew has a good point. So the data is listed in whole numbers, isn't it? Go back to the data, look at the data. The data we have is listed in whole numbers. So if our measurement of the data is only accurate to a whole number, then normally when we calculate the statistics, it only makes sense to go like one decimal place beyond that whole number. So you typically go one decimal place more precise than what the data is. So our data is in whole numbers, so we would calculate to how many decimal places then? One decimal place. Because if you look over here, I've got whole numbers, 82, 97, 84. So my measurement of the average, I usually round traditional rounding to only one decimal place. Now, if my data happened to be, you know, to some small level, like the 100th place of the decimal, then I would go to the 1000th place. That make sense, everybody? Because it's kind of an indication of how precise your measurement was. All right, so that's our mean. Any questions on our mean? So that's one indication, the middle, which would be, right about here, 81.9. That's great. Let's take a look at the second way we can get a sense of the middle, and that's called the mode. Or, excuse me, let's go to the median, I'm sorry. Now, the median is the middle number, middle data number. Middle piece of data. So the middle piece is pretty easy to identify if I have an odd number of pieces of data. Like, for example, if I have 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7 pieces of data. I can line them up in ascending order. And it's pretty easy to see that this is the middle piece. 1, 2, 3 are before it. 1, 2, 3 are after. So that's the middle piece. That's not a problem. But we got kind of a bummer. We have 30 pieces of data. So what's the middle piece?
82.
We have to pick 2, which in our case means we have to go to we got 30 pieces of data. We got to go to the 15th piece of data and the 16th, because those are both in the middle, really. 15 and 16. There's really no middle in our case. We've got an even number. So the way to do that, an efficient way to do that, I think we did this maybe one time before, was we sorted our data. And I've actually got it sorted in mine, but if you go back to your calculator and you get to list 1, so I'm going to go stat, edit. See, that's my data's already sorted. So make sure it's in list 1, list 2, wherever you have it. And I'm going to put out here, and I'm going to say, I want to do an operation on a list, so I'm going to go second list again. And I'm going to go over to ops, operations, and I want to sort it. And in my case, I want to sort it in ascending order, so I'm going to say function 1. Now I have to tell it which list. Like here's list 1, second, list 1. Hit enter, and it's done, but I don't see it, so I have to go back to look at the list to see it. So hopefully, if you've done that, or do that, go back and look at list 1 in my case, mine is now sorted. How many people see something like that with their calculator? Okay, we all right? Generally speaking, all right? Okay, so now, I don't want to talk down to you, but when you read the calculator, it says list 1, and then in parentheses it says 1. That's the first piece of data. So that little 1 right there says that's the first piece of data. If I go down to 2, it says a 2. That doesn't mean there's 2 67s. That just means it's the second piece of data that you entered. Everybody okay? So we'd like to go down to look at the 2 middle pieces of data, 15 and 16. So there's 15, and very fortunate for us, 16 is also 82. So what you do if you have an even number of data, you take the 2 middle pieces and you average them. Well, that's pretty easy. Okay, somebody do some high-level math for me. What's that equal to? Good. Right? So our median is 82. Okay? The middle piece of data. Now, who cares about a median? I have an average. That's great. That's the middle. That's good enough. Well, anybody know why a median is important? Yeah, Joe?
It counts for like extreme values or doesn't include extreme values.
Yeah, so I use this story all the time, but yeah, Joe is right. It counts for extreme values. So let's take an example of where median would be much more informative than the average. Sarah, you're back in my good graces, and so now you're the owner of a company, and we're all employed by Sarah. We all work for Sarah. And Sarah loves to go around and tell her peers that she has this company, and the average salary is $100,000. The mean salary is $100,000. And her peers are wildly impressed. I mean, that makes Sarah a hero, you know, in all of the people that she does business with. How do you do that? Now, what Sarah doesn't tell anybody is that we all make $32,000, and she makes $1 million. But the average, the mean, is $100,000. That sounds like way more impressive than saying we all earn $32,000, doesn't it? That's because she's chosen to use what? The mean. And then you add them all up. And you add up all our $32,000. That's okay. But then when she puts the million on top of all of that, and we divide by 30, 32 people, it comes out with an average of $100,000. So I guess I would just say, I would caution you, know the difference, because the mean is it can be wildly exaggerated or distorted based on an extreme value. Like $1 million and everybody else is earning, quite a bit less. Does that make sense to everybody? Now, the median, which is the middle value, if somebody's really sharp in one of these conferences, okay, and they said, Sarah, that's incredible. The average salary is $100,000, and then they were really sharp, like Nick, who's taking statistics. He says, yeah, but what's the median salary? And said, well, we don't divulge that, right? Well, the median would be a better indicator, wouldn't it? It would be like what most people make. Half the people are below it. And if Nick was able to get that out of it, it would be $32,000. Right? That would be the middle value. That makes sense to everybody? So the mean is great, but it is very, very sensitive to these, extreme values. Okay, so let's look at the last of the